Curve C has equation y equals f of x, where x can be any real number, and then we're given the derivative. F dash x is 2x plus a half cos x. We're told that it has a stationary point with x coordinates alpha, and that alpha is small. We're asked to use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So cos x is approximately equal to 1 minus x squared over 2 for small angles. This is in the formula book. If you were to carry it on, it would actually then be plus x to the 4 over 4 factorial. So the terms kind of, we times the gap in by 2 every time powers. The next one would be then x to the 6 over 6 factorial. But we don't really cover that in A level. I'm just trying to demonstrate it. And that's why if x is small, it's okay. We can just get rid of these and the other ones because we're raising a small number to the power of quite a big number and then dividing by a large factorial as well. In any case, right, for us, we're trying to solve f dash x is equal to 0, the stationary point. And therefore, 2x plus a half. Now I'm going to replace my cos x by 1 minus x squared over 2 is going to be equal to 0. Technically, approximately equal to 0. Maybe I should say that, actually. Let's stick with that. Okay, I'm going to multiply this out. 2x plus a half minus x squared over 4 is going to be approximately 0. Then I'll times through by 4. So 8x plus 2 minus x squared is going to be approximately 0. X squared, I'm just going to make it the x squared positive now. X squared minus 8x minus 2 is going to be approximately 0. This isn't going to factorize, but I can use the quadratic formula. So we get 8.2426. I'm going to write alpha now. I could have put it in earlier. 8.2426. But then there's another solution, remember, minus 0.2426. The first one is not small. It's not the these terms wouldn't be small, so we're going to reject it. That's definitely going to have to be less than 0. Actually seems to be still quite big, but it is actually small enough to work for the small angle approximation. So that is our final answer. Well, let's just round it to 3 decimal places. Alpha equals minus 0.243. Just to show you, I did actually plot the graph. So what I decided to do was find out the original function. I integrated, which gave me y equals x squared by integrating 2x, and then plus a half sine x by integrating a half cos x. And I just added my own constant. It doesn't really matter because the turning point will be in the same place. And this is what we end up with, minus 0.2426. So they're actually very, very good. Approximation, it's got to be said. In part B, we're asked to find the equation of the tangent to the curve at P, 0, 3. So, okay, mine's actually worked out to be correct, strangely enough. So we're actually trying to find the equation where it just glances off like that. Okay, for this, we're going to need to use differentiation. Actually, we already have the derivative, remember. So we've got f dash x. We can just sub in 0. And x equals 0. F dash x is going to be 2 times 0 plus a half times cos 0, which is 1. It's actually going to be a half. Okay, so I have my x, 0. I have my y, The tangent, I can use y minus y1 equals m x minus x1. So y minus 3 is going to equal a half x minus 0, which is just x, and we're there. Y equals a half x plus 3. So this question is just a little bit different because we're actually given the f dash x. We didn't have to differentiate, but we did have to use the small angle approximation and then do this bit at the end with the tangent, but that is our final answer.